who's logged on. This recorded online training event and the handouts from this session will be available later today on the ActOnEnergy website on the Education and Training page. And I wanted to let you know, if you have any questions during the presentation, please type them into the chat feature on the right-hand side of the screen and hit send, and then we will get those questions answered for you. And also, after the session, I'll be sending you a survey, so please provide me with your feedback. And this event will last about 60 minutes. So first, what we're going to do to get started is I'm going to ask you 3 questions to find out what you already know about energy management systems. And I'm going to open that poll, and once you have chosen your answers, please click submit, and you'll have about a minute to submit your answers. I can see half of you have gotten your answers in, so I'm going to close the poll here in just a few seconds. And I'm going to share the results with you. As soon as someone lets me do that, I will share the responses so you can see what percentage of people have chosen each answer. You can see the results. I'm going to get the same quiz at the end of the presentation so that we can see how much you learned about energy management systems, and so I'll go over the responses with you at that time. I'm going to tell you about the topics that we're going to be discussing today. Today we're going to talk about how you can save energy with an energy management system, include benefits of energy management systems, the different types of energy management systems available, specialty controls for industrial equipment, and how energy management systems can save you money. The information presented today is going to help you understand how these energy management systems work and how installing the energy management system, whether that's going to be right for you. Now, without any further ado, I am going to introduce Nate Opperman, who is a systems engineer with SAIC and ActOnEnergy partner, and he's going to tell us about energy management systems. Welcome, Nate.
Thank you, Mary. Good morning, everyone. I'm going to discuss here how to save energy using energy management systems. To start out, energy management system has the ability to let you see things based on the floor level, the equipment level, what's actually going on each piece of equipment. You're going to be able to step up the next level to actually see what's going on more on a building level. So you're going to be able to see what's going on in certain areas of your building. You have hot spots, cold spots, no issues with these areas. You're now going to be able to start monitoring these areas. And that you're actually going to be able to look at a management level. You're actually going to be able to look at your whole building and able to dispatch areas where they need to go, or your equipment actually is going to be able to tell you when things are going wrong. You're also going to be able to start doing some lighting and some other and interesting things system as you get more advanced. So the basic benefits of an energy management system that you're now going to have remote system access anywhere in the world if the system is set up correctly. So let's say the facility manager and you receive a call from one of your maintenance guys at 3 o'clock at night or in the morning saying that certain plant isn't actually getting any heat in the middle of winter. Well, instead of having to run to the plant and actually find out what's going on, you can actually log into your management system and say it's U5 up in the corner that's not providing heat, and it's because we have a temperature thermostat trip designed to protect the chill water coils from freezing. So now you're actually going to be able to call back that maintenance guy and say, oh, well, this is the problem. This is what you're going to need to do to be able to fix it. You're also going to have the ability to have remote alarm notification. What a remote alarm notification is going to be able to do is allows the system to actually have numbers of your maintenance people set up that, let's say, go down that's productive critical, it's going to notify your maintenance guys as soon as the system goes down. So then act on that and continue production at a facility, or let's say a smoke detector trips in one of the units in a commercial building. You're now going to be able to know as soon as that happens, turned off, and it turned off because of a smoke detector trip. Those are some of the maintenance abilities that's going to allow you to help stay on maintenance and a lesser stance save money on energy. The energy savings, starting with the base bundling, you're able to monitor and do surveillance of your overall building as your building and as your equipment. What this is going to allow you to do is actually start looking to a better idea for which a huge one we see is setpoint standardization. A lot of times without a building system, certain areas of your building are going to be a lower set point than where, let's say, your corporate standards dictate or where your office level dictates. You're not able to take a quick glance at an overview screen and say, oh, well, these units right here have been tampered with. We need to go back through and reset them. So on the addition of having to send this guy out to manually adjust the thermostat, you can now do it from one remote location and building wherever the computer is sitting and adjust those status. You're also going to get equipment status. So if it's running, if it's not, if let's say it's a real stay out and you should be bringing in a lot of outside air and you notice the unit's not, well, you can then tell a maintenance guy, oh, we probably have a problem with damper. They can go out and take a look at it, see if it's actually doing it right, or it might be a controlling issue that needs looked at. Through monitoring and surveilling, you're also going to be able to pick up utility meters either from the electric or gas, water even, or you can even do a sub-meter for each individual unit in your base, in your facility, or you have large equipment. Let's say you have a chiller and a boiler. You want to monitor how much those individual pieces of equipment are actually consuming. You can now pick up that sub-meter data. You can actual idea how efficiently those pieces of equipment are running. And also tie in with actual weather data. If in the advanced units, if the weather is going to be hotter outside, you can actually have your EMS system take a look and say, oh, well, it's supposed to hit 90 today. I try to pull in as much outside air as I can while it's cool out, in the 60s and 70s, so I don't have to overcool as the day goes on. You can do demand limiting. So now with an EMS, actually taking a look at what's going on in the overall system, you're getting hit with demand charges, you can look and say, okay, well, I get hit with demand charges during the hours of 1 to 3 in the afternoon. So instead of trying to run all equipment all day, you can now take your energy management system to say, okay, well, during the hours of 1 and 3, I want to disable these handlers and these portions of my facility because disabling them will not cause production issues and there aren't too many people associated with the area. So I can get away with not heating or cooling these spaces for a couple hours. Also have the system do cycling, where you can cycle a piece of equipment on and off every half hour or so just to try to trim some of that load or just help save on costs. We've already talked about the thing of breakdowns equipment remotely, and you can also generate a maintenance schedule through some energy management systems where, like, you need to change your filters quarterly. You can now set it up so it will alert your maintenance staff that, hey, you need to go change the filter for these units, so then they can test that and be so they process the worker and then mark it off as completed. The next main thing with maintenance is being able to have remote operation and control of the equipment. Be the simple fact that someone might have off a piece of equipment, walking on it and forgot to turn it on. You can now actually remotely access that piece of equipment and turn it back on if everything was set up correctly. Operation is a great way to help troubleshoot things and also get a feel for how your facility is actually currently running. You generate trend and operational logs for how the facility is actually running on an equipment by equipment basis on certain messes. What trends are going to be able to do is you're going to actually be able to see how the building loads up and sheds its load throughout the day. Also be able to see if your schedule is actually working to help give you energy and money in those. You're also going to be able to see if the unit is actually working efficiently. We've come across in our experience of thinking that a water valve or a hot water valve may not be actually opening or closing like the equipment says it is, and spots are getting warmer and cooler than they should, and being able to look at a trend and actually see that, well, the valve actually isn't doing anything is beneficial, just so that you can actually diagnose the problem and send us out to fix it. You'll be able to look at what kind of demand profile you have, if getting charged demand or electric bill, to see where in correlation your physical demand charges come in and how much load you have during that time to see if you can shed load. You also come up with, through training, conservation documentations. Let's say you decided to switch out less efficient motors for efficiency premium motors. You're now be able to see through the trend, okay, this is what the unit was running a year ago. Now looking at how the unit is running here, you can see the actual reduction and be able to justify the savings that you have for that program and be able to possibly push management further to say, okay, well, we can prove that we have savings from doing this. We should implement this further across the board. So the question comes up now, do you have an existing management system? I already had a poll for this.
I'm pulling up the poll, And I'm going to share that poll with you here. Right. So, choose your answer and then submit it. And this is going to help Nate know whether the audience is made up of people who are looking at upgrading their systems or installing new ones. Looks like most of you have finished, so I'm going to get ready and close the poll here. 3, 2, 1. And waiting here a second for the answers to download, and then I will share all the results so you can see what everyone else has answered. Thank you much, everyone, for your responses, and it looks like we've got split. 12 of you yes, 18 no, if don't know. So it gives you some information there.
Oh, thank you, Mary.
Thanks.
I'm going to touch quickly on some of the older style that have been installed in pre-stations, and I'll move over quickly to the direct digital controller, DDC as they're known. You have basically 3 types of EMSs that are commonly installed. You have your old style relay driven, which an example is shown inside. Of pneumatic, which is older buildings, older installations, and then the new direct digital control DDC type came out about in the late early 90s and has basically advanced and helped save energy in many different applications. So we have, this is a picture of a pneumatic EMS system. Pneumatic systems are pretty added. Like I stated, they're traditionally found in older facilities. The main issues with new controls is issues. It's hard to get a hold of some of the pieces of equipment, and gauge drift. Analog systems are honestly known for having accurate temperature, humidity, pressure gauges, just because over a period of time they start drifting. They need to be calibrated pretty much each year. And most often they're calibrated, they slowly start drifting, and you start running into problems where a system starts thinking that, oh, well, I'm discharging 55-degree air when it's actually discharging 50-degree air, or chill water supply system says the system thinks it's providing 55-degree water, but the chiller is actually providing 45, so it's trying to push the valves open further to cool more when it doesn't need to be done. So get to the direct digital control systems, or DDC. This is just a basic example of a DDC system that's shown here in the slide. We found through our installation of DDC systems, they're your best bang for the buck. They have rate of return, also are the most customizable available out there. Well, I guess that's later, so we'll continue on if I can.
Are we ready for the next question, Nate?
Yes, I think so, because I was going to say I lost the ability to click. So yes, we're ready for the next question.
Okay. Thank you very much. This is very interesting, Nate. I really appreciate you speaking on energy management systems today. And if anyone has any questions for Nate as he's talking, please feel free to enter the questions into chat and he will address those. So thank you again, Nate. Very interesting. Okay, so now I have another question for you. What energy management system do you have? So some of you have indicated that you do have an energy management system. So I've opened a poll and I can see people are putting in their responses. Looks like one person has a relay driven, 3 with pneumatic, and 10 with direct digital control. So it looks like most of you have put in responses, so I'm closing the poll, and then I'm going to share those responses with everyone so you can see what percent of people answered each one. Looks 15 of you that don't have an energy management system. Here, I'm going to share those results there with you. Thank you very much for your responses. And so it looks like the majority currently don't have one, but some people, looks like 11 people have a direct digital control. So that's very interesting. Now Nate is going to move on and tell us about how an energy management system specifically can save energy.
Thank you. So we'll start with the relay-driven energy management system. Our options are limited with basic scheduling and equipment control. It just comes down to you're probably using a mechanical clock to tell equipment to come on and off based on a certain time. It's very maintenance intensive because of that. And you're not going to be able to have a nice overview. You're not going to be able to control everything from one location. It's going to be it's going to be centralized in a large panel somewhere, and that's about as central as you're going to be able to get. And you're not going to get a lot of feedback based on how the equipment's running and what it's doing. You're just going to need to know if it's on or off. Your pneumatic EMS system, you're going to have a little bit more control. It depends if it's going to be a static or pneumatic DD hybrid. Basically, your pneumatic system is going to give you scheduling, but you're going to get some actual feedback from what's going on in the system. You're going to be able to get discharge temperatures, hot water temperatures, pop valve positions. The system's now going to be able to take in some outside air just to be able to deal with what's going on a little bit better. And you're going to be able to get some basic PID loops, going to be able to help control the equipment a little bit better, and going to be able to the equipment being on or off, as you're going to be able to slowly open valves or and VFDs up or down. Just being this quick off switch. I talked about the relay-driven, options are limited, pneumatic scheduling, instrument feedback. You're going to be able to utilize PIDs. EDC, you're going to have access to advanced scheduling abilities. You're going to be able to do your program in warm-up periods. So let's say your office opens at 8. At 7 o'clock, you can start turning equipment on so that you can take chill out of the air to help keep it more the climate a little bit better in the building. You're going to be able to do multiple steps. Let's say there's a conference room that you guys have that you want to be able to a little bit better, so you can actually have someone put in, let's say you know when exactly schedules take place between 1 and 2, 4 and 5, and other times you can actually hard schedule that in so the unit turns off while no one's in the actual conference room. If you're in an industrial facility and you work shifts, but one shift is in the morning and the other one's late in the evening, you can then turn everything off in the middle of the day to be able to save energy at periods. You're also going to be able to do demand load shedding. So if you know your peak demand load charges are, you can now go through and say, okay, well, I need to turn off these pieces of equipment on 30 increments over this period of time. You can set that schedule up, and the EMS will take care of it. It will say, okay, this time is hit, I'm turning this piece of equipment off, this piece of equipment is going off, and maybe something else is coming on just to try to even the temperature load off if you're doing HVAC equipment load shedding, or let's say you have a chiller, you're going to turn the chiller off during that time, you're going to use thermal storage tank to be able to cool.
I do have a couple of questions here for you. The first person is asking, what is PID?
A PID is a proportional energy derivative. It's a form of control. So there's actually a good example that is coming up that I can go in a little bit further in depth. It's actually after the slide, so I can explain a little bit better on what a PID does for you. If that's helpful, that one.
Okay, and then we have another question. How does the cost of DDC compare to the relay or pneumatic?
The cost of a DC is going to be, cost of a DC now compared to a pneumatic system is going to be dramatically less. You're not going to have the parasitic load of having to run a compressor, and it's easier to get a hold of the DC equipment currently. There are hybrids of a DC pneumatic system where there are pressure switches or control boards that you run a 4 to 20 milliamp or a 0 to 10 volt signal into that says, okay, this is what I need this piece of equipment to open slowly or close slowly or ramp up or ramp down, and it turns it over to a pneumatic for like a pneumatic valve, which systems, just as well as the DDC system, the main thing you need to do with the pneumatic system is get rid of your pneumatic temperature gauges. That's where a lot of your loss and energy savings are going to come from, because you no longer A, have to calibrate, and B, you actually know what your system is doing in time, and you're not going to get as much temperature drift.
Thanks for answering those questions. That's very interesting.
No problem. With the DDC system, you're actually going to be able to start trending points as well. It can either be stored locally at the DDC or through the EMS system. Trending is basically going to allow you to start pinpointing maintenance problems that you have in your building. Through my experience in these things, we will normally install an EMS system in a facility, and the facility manager will then call us up a week later after he's had time to look at it, and he goes, "You've broken all of my equipment." And the real issue is that his equipment hasn't been running efficiently before then. Having an energy management system, you can find out what's actually going on in your plant through trending and just monitoring the system and say, "Oh, well, I got problems here. I need to fix this." And you can now set up work orders, or you can start calling in experts that need to help fix problems. And being able to do that is going to be able to find hot spots, cold spots, chill systems running efficiently, heating systems running inefficiently, even put in a plug load monitor through panel boards. You can start saying, "Oh, well, why does certain circuits have a higher load?" And you can possibly find meters in a office space, because we know people bring in space heaters when they shouldn't, because they say their space is too warm or too cold. Being an EMS, you're going to be able to start pinpointing these things. And you're also going to be able to start enforcing better point standardization. That saving for set point standardization won't be EMS, but it will help the cost of the EMS over a period of time. This is the PI example I was talking about earlier. P is proportional, integral, and derivative control. And the example shows we have an input coming in is not shown on here, but basically our set point is this red line where we want to get. So we analog value coming in that we're trying to control to this set point. So what PID does, it allows, instead of turning it on and holding it on for a certain point and then overshooting that set point and turning it off and letting it drift below the set point and then turning it back on. So we're wasting a lot of energy by overshooting the set point over a long period of time. What a PID does is it allows a set point to be a set point to come to at a more reasonable and less intensive way. So we're going to we turn on a air handling unit to cool the space to 72 degrees, and this is at 74. So the DC controller is going to do the math and figure out, okay, well, I need to evolve to a certain. So PID is going to say, okay, well, I'm going to take that valve number that it needs to be open to, and I'm going to slowly approach that. So I'm going to overshoot, or the set point, but what should be open to, but what the discharge temperature should be. So I'm going to take a look at, okay, this is what the discharge temperature should be. I'm going to take that number and slowly open the valve, so I'm going to overshoot this temperature. So the valve will open to a degree depending on how the PID is tuned, and it's going to overshoot the set point slightly. It's going to, oh, well, I need to start backing the valve off. So it's going to back the valve off and to see in the example, come just below the set point, and then it's going to slow open the valve until it hits and then it's going to hold the valve at that set point as long as that set point stays. If the set changes, it's going to either open or shut the valve depending on where the value goes. So instead of this overshooting each time, let's say 1, 2, 3, 4, 5 squares up and then 5 squares below the set point, you're only going 5 squares above and a quarter of a square below. So that's all energy you're saving. PD is a wonderful way to energy, and it's a wonderful ability to have the DDC system. As an EMS, you're now going to be able to network all of your equipment together. Additionally, with a system, your HC equipment doesn't know what your chiller's doing, and your chiller doesn't know what your AC equipment's doing, and the water system doesn't know where it should be, and if water shouldn't really technically be on, if the chilled water should be on. So all this equipment's running independently. Being able to network everything together, you're now going to be able to have a balanced system. The chiller is going to know, oh, well, there's so many valves open, I don't need to be producing as cold of water as right now. So I can back off on chilled water, so I can maybe produce 47 degree chilled water instead of 45. And, oh, well, someone's boiler should be on, but the boiler shouldn't be on because it's 8 degrees outside and no one's hot water right now. So I'm going to keep the boiler off. Having a balanced system, it's going to help a lot of wasteful energy, and it's going to be able to give you a better balanced system. It's going to increase comfort in building, and which we all quantify, but a more cool building helps improve productivity.
Okay, so now we are going to talk about the ActOnEnergy incentive areas, and I am going to introduce Chris Durand, who is an energy advisor with SAIC and ActOnEnergy partner, to tell us about the ActOnEnergy incentives. Hi.
Hi, thank you, Mary. Also, thank you, Nate. For those of you who are unfamiliar with ActOnEnergy. It's Ameren, Illinois' program that offers to customers to be more energy efficient. Energy efficient upgrades not only lower your energy bills, they can also reduce maintenance costs, improve comfort, provide precise control, and extend equipment life. All good things that affect your bottom line. The initiative helps businesses less energy and save more money. The ActOnEnergy program includes electric and gas incentives. The incentive is going to be paid directly to the customer after the project is completed. There are energy saving products available at the ActOnEnergy online store, which you can see the web address there at the bottom of the screen there.
We do have one question for you about the ActOnEnergy incentives.
Okay.
Someone is asking, let's see, is there money available to update the old outdated systems as well as putting in new systems?
Short answer is yes. The ActOnEnergy program allows for upgrades that is based on just the amount of energy saved. So I mentioned some of these systems are pretty efficient because of gauges that don't work properly or overshooting set points. So if a new system is installed, there's going to be an amount of energy saved between the two systems, and an incentive can be provided for that amount of energy savings.
And then next year, you were going to tell us what exactly some of those incentives are.
Right. There are, as Nate mentioned, there are different components of that an EMS system can control, and so different incentives for those different types of upgrades. Lighting components, we offer an incentive of 5 cents a kWh saved per year. HVAC, motors, all sorts of other equipment that doesn't include lighting are offered, an incentive offered at 7 cents a kWh saved, and any savings are going to be incentivized at $1.20 per therm saved per year. One project can be a combination of any of these or all of these, so the project can have to be just a lighting project or just a motors project. We've seen complex EM systems that cover a broad range of things, so pretty much no limit with what you can control as long as the EMS system is capable of working with what you have. Nate's going to talk about some examples, so I'll go ahead and hand it back over to Nate.
Chris, we do have one more question for you real quick.
All right.
Someone's asking, if you upgrade to a DDC system, how do you estimate the kilowatt hours saved?
Well, that's a great question. It's a little bit of a tricky answer. The installer of the system is going to give you a better estimate of the system is capable of control and providing, and to have some base utility bills that are used to establish the existing usage. So really we would just do the difference between those two, and the incentive would be calculated. Later on down the road, after a year of having the new system, that you're in fact saving more energy or maybe a little bit less, but or about right, you have to make an estimate up front to provide the incentive. So with the customer and the installer of the system to come up with the best estimate of that using engineering calculations usually. That question?
That did. Thank you very much. We can turn this back over to Nate, and he's going to give us some examples of how this applies in the real world.
Yeah, so just a quick example of an industrial complex that we've done. Built had 8 AHUs, some door heaters, and a large industrial chiller. We installed multiple DDCs with the supporting equipment, so JACEs and in order to be able to tie into those. Project at over $750,000. The project was calculated to have a payback of less than 10 years. Mainly payback was large due to the industrial facility basically wasn't scheduled. Lighting was kept on most of the time. HVAC equipment was kept on most of the time. And the cash incentive for you guys would be about $100,000. And I will do a disclaimer. My SE does do EMS systems. The office I'm out of actually does these screens, so if you're interested. Anyway, this is an example of a powerhouse boiler system. And see all the different variables that you now actually have access to. Instead of having to stand in front of the equipment, you can access this remotely. Here's an example of a chiller system. You can see your the pumps, amount of water flowing, speed, and the temperatures coming in. Example of a chiller system. You have your temperatures, you have your status, any kind of alarms coming through, the problems, faults. Active set point is the power factor that the chiller is causing and things like that. A actual example. We put EMS in a 75,000 square foot office building with 3 HUs with multiple VAVs. Unit all controlled by old pneumatic controls with inlet vanes and inlet on 10 and 5 horsepower vanes. We replaced the motors with high efficiency motors, changed the inlet vanes over to VFDs, and added DDC controls throughout the whole system. Roughly calculated the at $65,000. The total savings per year was calculated at $12,000. Payback was high due to the hours they were running the current equipment at, and set points were not near the corporation standard. The payback was around 5 years. Some examples of EMS screenshots. The commercial facility, you can actually see each zone, what the temperature is. You have occupancy set for heating and cooling and unoccupied for those for hours when the equipment isn't on. An actual layout of an HVAC equipment, which cooling coils are on, which heating coils are on. This unit's actually with electric heat. Fans on auto or smart, unoccupied, occupied. And then your set points at the equipment. Here's a trend or a tabular screen, so you can actually look at your whole facility and just quickly glance, am I meeting space temp set points, and if my unit's actually running or not, and if I have a fault or there's a warning. Trend screen, so you can actually go through and see the unit's cycling on and off, and you can see how the temperature is degrading based on when the equipment turns on and off. Full of a schedule and how you can actually set up a schedule within an AIC system. Pretty forward. Their zone layout for you can see which units or which systems are actually on and which ones are off. Point scheduling. As for example of a hotel system, we have recently calculated energy savings for a hotel with roughly 9 rooms with 49 existing external thermostats to the ductless splits associated in the room. After you install the rooms with thermostats with an unoccupied temperature setback and temperature set points that are enforced by an EMS rather than a room. So let's say you don't want the room to drop below 68 degrees and you don't want it to get any warmer than 72. It'll be physically enforced at the thermostat, so someone at a hotel can actually drop it below those, because we are when you go to hotel rooms, we drop the thermostat either really high or really low depending on what type of person we are. This will prevent that. Figuring the energy calculations, figuring that rooms are unoccupied for between 8 and 4 during the week, and weekend and holidays it's between 9 and 8. You're really saving about 457,000 kilowatts, which figures to about $41,000 per year. The implementation cost with labor and switching out the thermostats to be about $35,000. You're looking at a simple payback of about a year. It's purely theoretical. We haven't had a chance to actually implement this yet, so the time frame could increase or substantially, but it's still well within 5 years and under. So Chris is now going to provide an example of an energy management system in a retail store.
Thank you, Nate. This retail store example, the system was going to controls the HVAC set points, the ventilation, and duty cycling HVAC. It also controls lights and light levels, uses CO2 readings, photo sensors, and hours of operation input to assess and adjust the HVAC and lighting. Examples of how it worked is this particular facility has storage in the rear part of the facility, and there's not individuals back there very often, so this MES is able to monitor when people are there or when lighting and ventilation is needed, and then it's reduced when there's no one present. The overall price for the project came at about $24,500, and the energy savings that were estimated, the initial payback was 3.8 years. We looked at this situation and we were able to offer an incentive of about $5,800 and drop the payback down to about 2.5 years. This done before we had the larger gas incentives available, so our new gas program allows for us to buy that $1.20 per therm saved. So the incentive for this could have been a lot larger with the gas savings, but we were able to provide an incentive for the cooling savings.
Chris, as we talk about these incentives, we had another question here. Someone is asking, are these incentives for a year or just for an introductory time? I think asking when they're available.
The program, the ActOnEnergy program runs all year, and we do the incentive calculation is based on a year's worth of savings, so that first year's worth of savings is calculate the incentive. At that first year, all of the savings that a customer will see will be on their utility bill.
That answers that question. Thank you.
Okay. So maybe on how to get started, to get one of these projects rolling. There's a couple that exist for customers. First is that the Smart Energy Design Assistance Center provides energy assessments and and they go through your facility and find areas that can be improved, guidance on what is to start on first. We also have energy advisors that cover different parts of the state. This map shows you where the energy advisors cover and contact information. You can contact them directly, and all of them are very versed in the energy program and have good backgrounds to help you on any type of upgrades you can you come up with. To get started is to contact and apply. Also, some people call them contractors. We call them allies because they work with our program. And they do energy management system project incentive. They have been trained on how our program works and have experience in conducting projects with ActOnEnergy. Find a list of programs on the website. You can kind of an example there in that screenshot. Also, ActOnEnergy website is good for other information, other electricity and gas savings opportunities. Also, that's where the online store is located. Also, some additional direct way information. Your website there, as mentioned, with a helpline or kind of a hotline, 1-800 number that you can call, and the info on there can point you correct direction. A lot of times they'll on to an energy advisor that's in your area, or send an email. If you prefer email, you can send it to the energybusiness@ameren.com. Questions and inquiries that way. Rob Rhodes, he's a great contact as well, and his number and email are available for you. And Jeff Brigham, a contact with the one that understands pretty much an aspect of our different apps, lighting, HVAC, motors, EMS systems, custom. So those are all areas you can look for to get started. Mary's going to finish off. Turn it over to Mary.
Thank you very much, Chris. So take our final quiz real quick, and then I do have a couple of questions for the presenters to address. So I'm just going to open the poll and see what you learned today. So if you could please take a moment to submit your answers. Most of you have finished, so I'm going to close the poll down in 5, 4, 3, 2, 1. And then I'm going to share the results with you and share the final answers. The first question, which of the following types are types of energy management systems? We learned today that they are direct digital control, A, D, relay, and E, pneumatic. Here are those poll results for you. People got those right. And then number 2, what cash incentive does ActOnEnergy offer natural gas savings realized by energy management system installation? The correct answer is B, $1.20 per therm saved. And three of the following are benefits of energy management systems. And the correct answer is C, they allow for remote system access, and most of you got that right too. So good job. Now I have a couple of questions here in chat that I will ask the speaker to address. So one person asked, please explain duty cycling. Address that?
Yes. So duty cycling is going to be used to help reduce your demand load charges. So instead of just turning completely off, let's say you have production critical equipment or for heating and cooling in an industrial facility, instead of equipment off, you're going to cycle it on and off on 10, 15, 20, 30 minute cycles. So it's going to be off for 10 minutes, come back on every 10 minutes, or off for 20 or 30 minutes and kick back on in another 30 minutes later. You're going to shuffle. It's basically a shell game. You're going to shuffle around where your load's going to be located at the plant. It's the best way to put it.
Great, thank you. And then another participant says, EMS systems sound like they can get complicated pretty fast. For example, would a local store manager at a retail store be able to use the system effectively if the store hours change?
On the system you choose. Some systems are definitely a lot easier to deal with, being able to change hours, and some can be overly complicated. Some can be as simple as set up a thermostat, programming a thermostat. So depending on the level technical degree that the store manager has, it can be completely doable, and sometimes it may have to be pushed down from a corporate setting.
Right. Thank you, Nate. Okay, now I have a question that probably Chris could address. How long will the ActOnEnergy incentive be available?
Well, we have good funding right now, so they are available in the funding. The ACT program's been going on for about 3.5 years. So far, we have been unable to run out of money, so there's a good chance that the money will remain there when you submit an application.
Great. Thank you very much. If anyone has any further questions, please submit those now. I want to thank everybody for attending today and want to let you know about a couple of upcoming webinars they have. October 12th at 8:30, we are going to be presenting Saving Money Through HVAC Efficiencies. That'll be very interesting. And November 9th at 8:30, we'll be delivering a webinar on boiler best practices for energy efficiency. And November 16th, 8:30, we are delivering energy efficient lighting options. And you can sign up for any of these on the ActOnEnergy website on the Education and Training. Well, that concludes our time today. Thank you everyone very much for joining us, and have a great day.
Thank you.